Today I'm gonna give you some question on Kohlrausch law. Then we will go for the next topic. Please do this. We need to calculate the equivalent conductance of BaCl2. Any answer, Austin?
Yes, sir.
Option number. Mom, are you able to solve this?
1 minute, sir.
Okay.
Sir, very sure how to do this.
Option number.
No, sir, can you show how to do this?
Okay, I'm gonna explain this. So if you were present in the previous class, so you need to calculate the equivalent conductance of BaCl2. So when we are going to talk about the equivalent conductance, first of all, you are going to dissociate this. Ba is barium from the second period element, so it will have +2 charge, and Cl has -1. To balance it, you need to multiply it by 2. Now, here is the important factor. In equivalent, we don't need to balance it. So I'm going to write here the equivalent conductance of Ba plus 2 plus equivalent conductance of Cl minus. So you can see Ba plus 2 has a value given, that is 127, plus for Cl minus it is given as 76. You just need to add it. 6 plus 7, 13, 7 plus 2, and 9 plus 1, 10. So this will be your answers. Got it, Austin, Umam?
Yes.
Okay. So basically this topic is very, very important, and that's why I'm gonna give you more questions on this. We're going to practice. Please do this question. Just wait a minute. Let me know when you are done with this. No, Mom, it's wrong. As I told you in the previous class, on the previous Tuesday, when we are going to talk about equivalent, we don't need to multiply with anything. Like you can see, in case of MgCl2, if you are going for MgCl2 equivalent to it, we are going to just write the Mg plus 2 and Cl minus, whatever is the coefficient, that doesn't matter in equivalent concept. Okay, equivalent conductivity or conductance. But when we are going to talk about molar conductance, then we need to multiply it or balance it in molar conductance. So the question you are going to see, as you can see here, that which of the following expression correctly represents the equivalent conductance? Equivalent conductance. We need to go for equivalent conductance at infinite dilution of Al2SO4 whole thrice. Equivalent conductance. If you are going to dissociate this Al2SO4 whole thrice and balance it, definitely you will get this 2Al plus 3 plus 3SO4 minus 2. But the question here is about equivalent, so we don't need to balance it. We need to just do this. Al plus 3 plus equivalent conductance of SO4 minus 2. We don't need to multiply it with any coefficient. But if there was a question, there will be question about molar conductance or molar conductivity of Al2SO4 whole thrice. Then you must balance it, must multiply it like equivalent conductivity of Al plus 3, and here you are going to multiply it by 2 plus equivalent conductivity of SO4 minus 2, and you are going to multiply it by 3. So see the difference between molar conductivity and equivalent conductivity. So according to this, the answer will be C, not B. Are you getting my point? Both of you?
Yes, sir.
So please do write it. Are you done with this?
Yes, sir.
Okay. Now I'm gonna increase the level of this question, and it's very, very easy. I think you can do this. Here comes the question, next question. Oh, let me know if you have any doubt in this. Will you be able to do it? If you are not, just let me know. Oh, very good, Austin. Very good. Mom, what about you?
1 minute, sir, calculation.
Okay, okay. Just do your calculation. Oh, very good, both of you. This question that I'm going to give you is similar to the previous one. This question number 6, and I think you can do this easily. Same answer means question number 6. Which option is correct? Very good, Austin. Very good, Uma. Very good. One more question I'm gonna give you. Please do this. Any answer? It's the concept is same, only the examiner played with the options. They just give you not the option that you have calculated. You need to check the option and accordingly you are going to arrange your answer. Austin, Umam,
Not getting, sir.
okay. I'm going to explain. Umam, are you there?
Yes, sir.
Okay, see, it's H2SO4 given as X Siemens centimeter square per mole, not a problem. You can see lambda naught H2SO4, lambda naught H2SO4, and it's given that the unit is Siemens centimeter square per mole. This unit represents that it is molar conductivity. It is what? Molar conductivity. Now see, since it is molar conductivity, you are going to dissociate it accordingly. H plus is here and lambda m naught SO4 minus. To balance it, I have to multiply it by 2. Yes or no? I have to multiply it by 2. Is there any problem here?
No.
Okay, go for the next one, and that is your K2SO4. Just wait a minute. There is a call from coaching. Okay, sorry. Now the next one, am I audible clearly?
Yes, sir.
Okay, lambda naught MK2SO4. I think you can process that. This there is 2 potassium, so I'm gonna direct multiply it by 2 M, and here it is for H plus, and here it is for SO4 minus. The last one is very simple, lambda naught M, and it is CH3C double OK, and it will be lambda naught M, and here it will be CH3C double O negative plus lambda naught M K plus. Is that clear? Sorry, yeah. Now we need to calculate lambda naught M for CH3C double OH. We need to calculate this. And if you are going to dissociate this, you know that lambda naught M CH3 C double O negative plus lambda naught M H plus. We need the value of this and this. Are you getting my point, both of you? Please do respond.
Yes, sir.
Now the problem is that we need CH3 C double O negative, which is directly given, but we need 1 mole of lambda naught MH plus, and in this 3 equation you have 2 moles of lambda naught MH plus. So in order to get 1 mole of lambda naught MH plus, I'm gonna divide this equation by 2. I'm going to divide this equation by 2. So it will be lambda naught m H2SO4 divided by 2. That will be equal to, if you are going to divide this, this will be equal to lambda naught m H plus, this 2 will be cancelled if you are going to divide by 2, and lambda naught m SO4 minus 2. This is the new equation, equation number 1 I'm going to take. Okay. Now, another problem begins after this. Now, you know that this has a value which is equal to x. So if you are going to divide this, now the value will be x by 2. Now, another problem arises due to this, because you have got lambda naught m SO4 divided by 2. And here, if you are going to cancel it, you are having 1 mole of lambda naught m SO4 minus 2. Now, this is 2. So I'm going to divide this next equation. Just wait a minute, I did a mistake here. There is k2, I wrote it here h plus, which is wrong. It's k plus. It's k plus. Now again I'm going to divide this equation by 2 lambda naught m k2SO4, which will be divided by 2, and it has a value y. Now we divided it by 2. That will be equal to lambda naught m. Now it becomes k plus, and then lambda naught m SO4 minus 2 divided by. Now the third equation, we don't need to do anything with the third equation. Third equation will be as it is, that is lambda naught m CH3COOH. That will be equal to lambda naught m, and that is equal to CH3COO negative plus lambda naught m H plus. Oh, wait a minute. Yeah. So the third equation is CH3COOK. So this will be as it is. Now, in order to get this and this, we are going to focus here and here. So this is your equation number 1, 2, and 3. So we need to add this. We need this and this. So what I'm gonna do is equation number 1 plus 3, and with equation number 1 and 3, we will get some extra quantity this. So I'm gonna subtract it from 2. So what we will get, actually, you can see, actually we will get for equation number 1, lambda naught m H plus lambda naught m SO4 minus 2, and from equation 3 you can see lambda naught m CH3COO negative plus lambda naught m K plus, and from equation second you can see we will get lambda naught m K plus. Since we are subtracting, so we are going to write it like this, SO4 minus. Also in the first equation it is this, so I forgot to write this divided by 2, and you can see that this positive and negative, there was this as well, I forgot to write it, cancel, and this will also be cancelled. So what we will have left at the end, lambda naught m H plus lambda naught m CH3COO negative, and together what it will give you, lambda naught m CH3COOH. Now whatever we did here, we are going to do that. One had a value x upon 2, and third has a value z upon 2, right? Third has a value z upon wait a minute, sorry, third has a value z, and second has a value that is y by 2. Yes or no? You can see from the equation above, first equation first has a value x by 2, equation 2 has a value y by 2, and equation third has a value z. So what we did here, 1 plus 3 minus 2, and accordingly you can do this. You can see the option was like this, and you can easily do this after taking LCM. The answer will be your A. This is your answer. So basically the concept is very easy, but you have to be careful because of these steps. So I want you to please do write it. If you have still any doubt, you can ask. Let me know when you are done with this. Let me know when you are done with this.
So could you scroll down?
Yeah.
Sir, can you scroll down?
Scroll up or down.
Down.
Let me know when you are done with this.
Done, sir.
Very good. Austin.
Yes, sir. Done.
Okay. Now I'm gonna give you another question. This topic is very important. That's why I'm taking it seriously, and so do you. So this is the last question on this. Calculate, and very easy it is. Lambda naught n for NaOH, sodium hydroxide. Just wait a minute. It's not NaOH. It's ammonium hydroxide, NH4OH. Given that values of lambda naught m for BaOH whole twice BaCl2, it's similar to the previous one. The questions on this topic is very similar to each other, as 523.28, 280 and 129.8 Siemens centimeter square per mole respective. You can easily do this. Uh, will you be able to solve this?
Yes, sir. Trying, sir.
Okay. Yeah. Good, great. Imam, are you still calculating?
Yes, sir.
Okay, just let me know. I'm gonna write another question. Till then, you are solving the previous question. I think you can easily solve question number A and B. If you are not able to solve C and D part, I will give you. Oh, very good, Umam. Great. Please do this question. Molar conductivity is given. Any answer? The first question is very, very easy. Yeah, B part. No, it's 10 raised to the power minus 4. Okay. It's slightly mistake. I'm gonna show you. If you are going to solve the A part, conductivity. Conductivity, that means kappa, will be equal to, if you remember this formula, cell constant upon resistance. Austin, have you remember this formula?
Yes, sir.
Cell constant has a value 0.366 and divided by the resistance. Value of resistance, let me check it. It is, oh, I had given a wrong value. According to this value, answer is correct. Actually, in the question, it is given 2220 ohm. So according to the previous question, Muhammadin, your answer is correct. Okay. So it is basically 2220 ohm. So if you are going to divide this, you will be getting 1.6 into 10 raised to the power minus 4 Siemens centimeter square. Siemens per centimeter square. Siemens per centimeter. Please give me the answer for the B. B is very, very easy. Oh, very good, Austin. That's correct answer. Any answers from Mahmoudin? The B part is very easy. Molar conductivity of what? Molar conductivity we need to calculate for CH3 double OH. And you know, molar conductivity, you are going to dissociate this CH3 double O negative plus lambda naught M H positive. Now, you can see this has a value that is given as what is the value that is given? 349.1 plus 40.9. If you are going to add it, you will be getting 390 Siemens centimeter square per. This will be the answer for the B. Now, if you are looking for the C, for C, we need to calculate degree of dissociation. And this has a value lambda m upon lambda naught m. Lambda m is the molar conductivity at any concentration, and lambda naught m is the molar conductivity at infinite dilution. So if you are going to put the value, it is given that 16.48 upon lambda naught m that you just calculated, this lambda naught m infinity at infinite dilution, that is 390. So if you are going to solve it, you will be getting 0.0422. So this is the value of alpha. Now, if you are going to calculate the dissociation constant, as I told you, this is CH3 double OH is an acid. So dissociation constant is also known as acid dissociation constant, and which has a value Ka. Ka will be equal to C alpha square upon 1 minus alpha. As you can see, the value of alpha is very, very small. So this will be neglected. So if you are going to neglect it, it will be equal to C alpha square. C has a value. If you are going to check it, what is the value of C? C is the molarity or concentration, and it has a value 0.01 that is given in the question. So you are just going to put the value 0.01, and alpha is a value 0.0422 whole square, and accordingly you can calculate it. Is that clear? The answer will be 1.78 into 10 raised to the power minus 5. So please do remember these formulas. This formula comes from class 11, ionic equilibrium. Is that clear, everyone?
Yes, sir.
Yes, sir.
Okay, so this is it for today. I will see you in the next class. Okay. Thank you. And you are going to study about the electrochemical series. Sorry, electrochemical set.